Hello everyone, welcome to the webinar. Today we are going to discuss the first section of the unit fractions, which is the second unit in General Math 1. We chose to dedicate some webinars for that unit because we get lots of questions on that unit. It is a challenging unit, and fractions is having its own rules that we need to follow in order to solve the problems that we may see in the practice questions or the self-checks or the exam. So that's why we dedicated as a department just to dedicate some webinars and live webinars for you to ask questions and look at the material from another perspective from a webinar instead of just reading the material from the study unit. Today we are going to cover the basics of fractions, which is the first section of the unit. My name is Mariam. I'm your math instructor here at Penn. I teach high school math in the state of Pennsylvania. I am finishing my master's as well. I'm hoping by December I will be getting my master's in education. I like to teach math, and it makes sense to me, a lot of sense, and that's why I like to teach this subject. And I hope by end of this webinar you will find it too that fractions is part of our lives and that you make sense of fractions. In this webinar, fractions will be discussed. Fractions is part of, as I said, General Math 1, but also if you're doing Consumer Math Part 1, it has some section on the first part on fractions. So if you're doing that course, you're welcome to attend Business Math, which is another elective that we offer. It has some on fractions. If you're doing no math courses right now, you're welcome to attend because I believe that we need fractions in our lives and we use them. So if you're just here to refresh your memory on how to use fractions or how to understand fractions, you are welcome to attend. During this webinar, we're going to have some self-check questions. So we're going to have a discussion on a topic on the section of the unit, and then we're going to have a question for you to try after that discussion and see what you do. Did you get the idea? Do you have questions? You may want to think, well, I need to go back to the unit because I'm not sure about that topic. So it's a self-assessment tool that we or I decided just to include in my webinars so that the webinar is helpful to you and also to myself. If I find that most of you are getting the questions wrong, it means that you need maybe to revise my webinar. I need to teach it another way. Maybe I need to change the order of my slides. So it is a feedback for myself as well. Your questions are welcome. Please keep your questions relevant to what we speak about in the webinar. If you have any general question on the course or any other thing that you may think of about math or maybe about Penn, you can keep that at the end. Or if you want to type it in the questions box, I'm going to answer that at the end of the webinar. The raise your hand feature is not enabled, so if you have questions, you can just type them in the questions box. All registrants, whether you are attending here or did not have a chance to attend, you will receive a recording of the webinar in a follow-up email. Usually the email, I send it out a couple of days later. So keep an eye on that email. It will have the recording of the webinar, so you're able to watch it as many times as you wish. Today we will cover the basics. What are mixed numbers, proper and improper fractions? How would we compare fractions? How would we find a common denominator, or in another word, how would I find an equal fraction? All of that will be an important information and important knowledge for us to know, so we're able to add and subtract and divide and multiply. Without these skills that we're going to discuss today in the webinar, we are not going to be able to properly add and do the other operations on fractions. So why do we study fractions? Why is fraction part of our studies in that course? Well, fractions is around us. We use it. Fractions is a way to express express things out of whole parts. So if I am saying that I am paying 1/3 of my income in rent, so I am describing a portion of my income goes to rent. I was driving the other way on the highway, and I saw the signs, the green signs, the little ones on the side where it says, for example, the 87th mile and 1/8 of a mile. If you do not know what 1/8 means, then you're losing here the information that they are putting on the sign. So, I mean, fractions is just a way to describe data, like percentages, for example. If I'm saying that the population of certain country has a certain disability, for example, and I'm describing that this part of the population in percentage, I am using percent or percentage to describe. The same thing with decimals and so on. So we need to understand how fractions work. If you just joined us in the webinar, the raise your hand feature is not enabled. If you have questions, you can type them in the questions box. So fractions, as you know, or I'm sure most of us know how to write a fraction. So a fraction, for example, if I'm going to write 4 and then over, for example, 12. 4 is a top number. We call that numerator. Numerator. And then this number, the bottom number, is the denominator. Now, the sign here is a division, actually. We are dividing 4 over 12. So what does that fraction mean? It means that I have 12 parts, a total number of 12 parts. For example, if I have a cake and I cut that cake into 12 parts, so the one whole cake is represented by the 12 parts or 12 pieces, and I ate 4. So I can describe the amount of cake I ate by the fraction 4 over 12. I ate 4 pieces out of a total number of 12 pieces. So this is what a fraction means, a part out of a total number of items or figures or pieces and so on. Now we need to also think of fractions in another way. Sometimes we look at fractions, two different fractions, and we think they are so different. They do not have the same value. But if we look closer in these or onto those fractions, two fractions, we will realize that they may have the same value. And in this case, we call the two fractions equal fractions. How do I get to these fractions? So if I have a fraction given to me, how would I be able to get an equal fraction to that given fraction? And that's why I have the slide with the pizzas on, and that figure, I guess, from your study unit. So we have 3 pizzas here, and you can notice that each pizza is the same size. This pizza, the same size as that one, and the same size as that one. The only difference is this pizza was originally cut into 8 pieces. Now, how many pieces left on the tray? 1, 2, 3, 4. So I can represent the portion of the pizza that is left on the tray by the fraction 4 over 8. Okay, the second pizza, it was cut originally into 12 pieces, but only 6 were left. So I can describe using the fraction 6 over 12, the amount of pizza left on the tray. The same thing here. That pizza was cut into 16 pieces and only 8 was left. Then 8 over 16 is the amount of pizza left on the tray. Something I notice in common between these 3 figures isn't that each of the figures of the pizza represent also a half of the pizza. So this pizza actually is a half of the whole pizza, and this too is half, and this too is half. That tells me that 4 over 8 or 4/8 is actually a half. The 4 over 8 fraction looks so different than the half, but the core value of 4/8 is actually a half. In this case, we say that half and 4/8 are equal fractions. Same thing here, half and 6/12. They look so much different, but they are equal fractions. And the same thing with the third pizza here. Now we understand that with the images. How would I do that with math? Just literally just with math, no images, no representation for the fraction. How do I do that? If I am given a half as a fraction, and then I'm asked to find an equal fraction to the half without looking at any images. How do I do that? The way I do that is to choose any factor. To choose any factor. Let's say 4. If I want to choose 4 to get to another equal fraction to half, so I'm going to multiply the 4 times the 2 times the denominator, and also I'm going to multiply the 4 times the top number, the numerator. And it is a rule in fractions. Whatever I do on the top, I need to do exactly to the bottom. Or whatever I do to the bottom part, I need to do on the top. So I would keep my fraction the same value. From here, I'm going to multiply each number times that factor. 1 times 4 is 4, and 2 times 4 is 8. I got 4/8 as an equal fraction to 1/2, which is this fraction, by the way. So this is how I used only math to arrive to an equal fraction of half. How many equal fraction exists for one fraction? Or how many equal fractions exist for 1/2? It's infinite numbers. It depends on which factor you want to choose to arrive at that equal fraction. I can choose 13, 17, 2, 1. 1 is not going to help because 1 times 1 is 1, and 2 times 1 is 2, is going to stay at the half. But I mean, you can use whatever factor you want to use. Depends on the question. Depends on the question. What is the question asking you to do? Is it asking you to find any equal fraction? So at that time, you will be free to choose any number or factor you want. If they specified which denominator or numerator the equal fraction will have, then you need to think about the factor. Which factor I need to use? Any questions here on this slide? Any question, anything that was not clear? You can type your questions in the questions box if you have any. So let's move to the next slide. And the next slide ties into what I was just saying. If I am given a problem like that, A, find the equal fraction to 10/15 so that the equal fraction has a 60 on the denominator. How would I do that? How would I find the top number of my equal fraction? I need to think of a factor that I multiply the 10 times and the 15 times so that when I multiply the 15 times, it should give me the 60. So what is that factor? What number I can multiply 15 to or times, and that will give me a 60? What do you think? It's 4. Okay, you may ask me a question. How do I know it's 4, not 6, for example? You can use your calculator. You can figure this factor out by dividing. Divide 60, which is the new denominator, over the old denominator, and that will give you 4 as a factor. So you will know that you have to multiply 15 times 4, and remember that rule that we spoke about? Times 4 on the top to keep the fraction balanced. So 10 times 4 is 40, and then I have the 60 already, so this is an equal fraction to 10/15. Let's do B. The same concept, just different numbers. 4/9 is the given fraction. What other equal fraction to this fraction so that the equal fraction has 108 in the denominator. In another word, 9 times what will give you 108? I need to figure out the factor. You can just say right away it's 12. Or if you're not sure, divide. 108 divided by 9, it should give you 12. So 12 is your factor. Since I multiplied 9 times 12, I need to multiply 4 times 12 as well. 4 times 12 will give you 48. So 48 over 108 is an equal fraction to 4/9. Last question, the same. 2/6 equals to what over 144? What factor I need to use? 6 times what? 6 times 24. If you're not sure, you know what to do. And then multiply 2 times 24 on the top. 2 times 24 is 48. And this is one of the equal fractions to 2/6. That's it. So it is really about finding that factor that would work with you to find the equal fraction. Any questions? Anything that was not clear or didn't make sense? This webinar is a live session. I like that we offer live sessions because that way our students are able to ask questions. Okay, why did I use 4 in A? Ashley is asking, why did I use 4? Is it number A or the previous slide? A. Okay, so let me erase then this and do this one more time. So let me erase that and go over that one more time and then explain why we used 4. So now the question is asking, this is the fraction you're given, and you need to find an equal fraction to this fraction so that the equal fraction has a 60 in the denominator. What times 15 will give you the 60? You may say, well, 4 times 15 gives you 60. Or if you're not sure, use the calculator. 60 divided by 15 will give you the 4. So times 4 and times 4, 15 times 4, of course, is going to give you 60, and then 10 times 4 will give you 40. And that's why I decided 4 is the right factor to use. I hope I answered your question. Okay, let's move on to a self-check question. So this is the self-check question I was mentioning in the beginning of the webinar. These questions will take like a minute or something for you to try and see, did you get the idea of finding an equal fraction to a given fraction or no? My screen or your screen will change and give you that exact question and also 4 or 3 possible answers, and you need to choose the one that you think is right. So in 1 second you will see the screen changing, and here you go. What would be the numerator of an equal fraction to 7/11 if the denominator of the equal fraction is 121? Okay, for these questions, I'm gonna share my answer, my final answer, and if it happens that you need more explanation, we can do that. So what factor I need to use? It is 11. So times 11 and times 11. Why? Because 11 times 11 will give me that number on the bottom, 121. 7 times 11 will give you 77. The right answer is 77 over 121. Okay. Now, how do we compare two fractions? Those bubbles, by the way, they have in my slides will summarize the rules that we use with fractions. Either it's comparing fractions or changing a mixed number to an improper fraction. So those rules, just say, you know, like a shorthand of the rules that you have in your study units if you would like to copy them down in your notebook where you refer a lot. So if you are doing your practice questions, you are not going back and forth through the unit to find that rule. How do we compare fractions? Let's read the question. Would you rather having 10/14 of a pie or 4/7 of the same pie? So in our mind, we are imagining two pies of the same size. One is cut into 14 pieces and you are offered 10, and the other one was cut into 7 pieces and you are offered 4. Compare the fractions, compare the offerings that you have from both pies and see if you, of course, want a lot of pie, you're going to look for the fraction of the larger value. If you are not the kind of person who likes sweets, then you're looking for the smaller fraction. So still you need to compare. How do we compare? One, we cannot compare fractions with different denominators. I see 14 and I see 7. I cannot compare two fractions with different denominators. And also I have different numerators on the top. I cannot do anything here. I need to do a step before I'm starting to compare and decide which one I'm going to go for. So let's write these down together beside each others and then see what we can do. To compare these two fractions, I need to find equal fractions for both or maybe one so that the fractions have the same denominator. What can I do? I have a 14 on the denominator and 7 in the other denominator. When I see 14 and 7, it just comes to my mind that, well, I can easily change the denominator of the 7 to 14 by multiplying the fraction top and bottom times 2 and times 2. Why times 2? Because 7 times 2 will give you 14. So the equal fraction of 4/7 is 4 times 2 will give you 8 on the top, and then 7 times 2 will give you 14 on the bottom. I have 14, and I already have a 14 in the denominator of the other fraction. Now I have both numbers in both denominators. Now I can compare. So here's the fraction. I didn't touch that fraction because it already had my 14. I only changed that fraction to an equal fraction. So the rule says if you are comparing two fractions with the same denominators, the fraction with the larger numerator will have a larger value. In this case, we can say that 10 over 14 is larger than 8 over 14. Now, if you want more pi, you're going to go with this fraction. If you want less pi, you're going to go with this fraction. Any questions here? Do we understand why did we have to find an equal fraction to 4/7? If no, just, type no. If yes, then don't type anything. Okay, let's do the same thing with another case. So this is case 1 when you have different numerators and different denominators. This is what we do, and it's written here on the rules. Okay, well, let's look at another two examples. Would you rather having 1/10 of a cake or 3/10 of the same cake? I see something here that makes my life easier. I see a 10 and a 10 in the denominator. So I have 1/10 and I have 3/10. Which one is bigger? Which one is smaller? Compare. I have the same number in the denominators, then just compare the numerators. The rule again says the fraction with the greater numerator is the greater value. So we gonna write this sign in between. 1/10 is less than 3/10. That was easy. This is case 2 when you already have common denominators. Let's look at case 3. Would you rather having 4/6 of a pizza or 4/15 of a pizza? Let's write these down beside each others and then see what we have. 4/6 or 4/15. These two fractions do not have the same denominators, but they have the same numerators. I need to use that. There is a rule for this kind of comparison. If you have two fractions, here is the rule. If you have two fractions, they have different denominators, but they have the same numerator, then the fraction with the less denominator will have the larger value. So this fraction is larger than this fraction. I had some questions on these rules over the phone and they were asking what is the reasoning behind that. So I would like to share that with you if you happen to have the same question. So if I have a pizza and I cut that pizza into 6 pieces and I offer you 4, and then I have the same size of the pizza, I'm gonna cut it into 15 pieces and I'm gonna offer you 4 as well. How much pizza is more? Are you gonna get more pizza from the one that was cut into 6 or the one that was cut into 15? Well, the common sense says if you're cutting the same size pizzas, 1 into 6 and 1 into 15, then the one that was cut into 6 pieces will have larger pieces. So in that case, in this fraction, you have 4 huge pieces of pizza. In that case, you will have 4 tiny pieces of pizza. So that's why this fraction is a greater value than this fraction. I hope that explains why we use that rule if you have the same numerators. Okay, let's practice and see more of comparing fractions. So write greater than, less than, or equal to make each statement true. Before I go ahead with these questions, I'm going to remind you how we use these signs. So these signs open up towards the larger value. So if I have 3 and 2, I would place that sign. That sign opens up towards the larger value. If I'm comparing, for example, 1 and 5, then again the sign will open up towards the larger. I'm going to read it though as 1 is less than 5. Let's do A. 5/16 is what to 17/32? Okay, well, this is case 1. I don't have any common denominators or common numerators. Then I need to use case 1. Case 1 told us that we cannot compare fractions like that. I need to have common denominators in both fractions and then decide. I have 16 and 32. What is the common denominator I can go with so I am able to do little work and still be able to compare my two fractions? Well, I see 16 and 32, and I know that 16 times 2 will give me 32. And of course, I have to multiply on the top times the same number. So 5 times 2 is 10. 16 times 2 is 32. This is what I want. And then I still have 17 over 32. Why did I choose 2? Because 2 was going to get me to the 32, which is already the denominator for the second fraction. So this is half of the work. I didn't have to change 17 over 32 as well. So I'm using the numbers I have. I'm using my knowledge of the multiplication table, or I'm choosing my factor correctly. So I do less work, but still I'm able to find the right answer. Okay, so as far as now, I have 32 and 32. Rule says the larger fraction will have a larger numerator. Then I am gonna put that sign here, will open up towards the larger fraction, and my answer would be this. 5 over 16 is less than 17 over 32. Let's do B. And B is 6 over 11 is what to 6 over 21. This is case 3. Different denominators but the same numerators. Then the rule says the fraction with less denominator will be the larger value. So I'm gonna make my sign open up towards the larger fraction. 6 over 11 is larger than 6 over 21. See, straightforward. 5 over 14 and 9 over 14. I know it's going to be this sign. 9 is greater than 5 since we have the same denominators. D, 45 over 45 equals less than or greater than 1. The rule says, and many of you may know that, any number over itself will give you 1, whole 1. So 1,250 over 1,250 will equal to 1. The same thing, 45 over 45 equals to 1. That's it. Do you have any questions? Anything that wasn't explained well? Okay, let's move on to our self-check and try that question and see if you're able to compare these two fractions. Think about a factor that you can get to a common denominator using that factor. 75 and 25. Which case is that, and how would you compare the fraction? I'm gonna make that question appear in 1 second. Here you go. Actually, the question is compare 6 over 25 and 16 over 75. If I just close the screen that you have right now, I'm not going to be able to bring it up, so you are able to choose the answer. So it's 6 over 25 and 16 over 75. Okay, let me share my answer. And the answer is that the first fraction is greater than the second fraction. Now, it's a good thing to notice that 6 is less than 16. 25 is less than 75. It does not mean that 6 over 25 is less than this fraction. We do not go by how the fraction looks. We go by the rules of fractions. So even though it just, seems that 6 over 25 is less, but actually as a fraction, it's more. So we need to remember to use the rules, not to guess. Okay, let's look at the next topic. If you are given two fractions, like 5 over 30 and 1 over 6, and you are asked to find out, are these fractions actually equal fractions or they are not equal fractions? How do I answer that question? Well, we have a test or a way to find out the answer, and it is the cross multiplication method. And like this, like the name says, it's cross multiplication. We're gonna cross multiply, and the way we're gonna do that is cross multiply and cross multiply. 1 times 30 will give you 30. That's the product, the first product. And 5 times 6 is 30 as well. The rule says if the two products are equal, then the fractions themselves are equal. They are equal. So these two fractions are equal fractions. They look different, but they are equal. B, the same thing. Are they equal or not? Do the cross multiplication test. Cross multiply and cross multiply. 21 times 12 will give you 252. And then 4 times 60 will of course give you 240. The products are not equal, then the fractions themselves are not equal. Straightforward, I guess, right? The same thing with C, it should say C. 6 over 9 and 25 over 36. I have no idea until I do the cross multiplication test. Cross multiply and cross multiply. 25 times 9 will give you 225, and 6 times 36 will give you 216. And these products are not equal, then the fractions themselves are not equal. Any questions? I guess it's too easy, right? Let's have a self-check question just to make sure that you got the idea and you can do that yourselves. And here is the question. 17 over 34, is it equal or not equal to 41 over 82? And here is the question. Okay, let me share my answer. And when you cross multiply, you will find out that this cross product or that product will be 1,394, and this product as well the same is 1,394, and therefore we can conclude that these fractions are equal fractions. If you got that question incorrectly, please don't get discouraged. This webinar is not to judge anyone or to make you feel that you're not gonna never get fractions. It's just a way to tell you where to go back to the study unit and revisit that. Maybe you wanna call the school, maybe you wanna email the instructor, just a way to see where to go for help. And at the end, that will make you improve your score in the exam and also understand fractions. And these are not graded. I just forgot to mention because some students, they think that these are graded. They are not graded. These are just for you to self-assess yourself. Next topic, and it's so simple, but I needed to go over that because I found some confusion between equal fractions and the concept of like fractions. What is the difference between two fractions being equal fractions? I think we went over that. And the concept of two fractions being like fractions. Let me give you examples. So like fractions, we said 1 over 2 and 4 over 8. They look different, but they are the same value. Like fractions are easier. For example, if I have 2 over 10 and 5 over 10, these are like fractions. Why? Well, only because they have 10 and 10 in the denominators. They only have the same number in the denominators. I don't care of the value, if they are equal, not equal. Of course, they're not going to be equal because they have the same denominators, but they are like fractions. Another example, 3 over 13 and 12 over 13. They are like fractions. They are not equal fractions, but they are like fractions. An example of unlike fraction, 1 over 5 and 2 over 7. They are unlike, and the reason? Because they do not have the same denominator. Very simple. So when you are asked if they are like or no, just check the denominators. That's it. You don't have to do any calculations here. With the equal fractions, yes, you have to cross multiply and see if they are equal or no. Any questions here? Okay, let's get to the next topic, which is one of the most important topics that we need to cover in this webinar because we're going to use that method a lot in when we add or subtract or do any operations later on in the unit. How do we simplify fractions? So you can think about simplifying fractions as you are peeling off everything unnecessary in the fraction so you get to the core value of the fraction. Example, number A, 12 over 18 is not in simplest form. This is not a simple fraction. Why? Because there is a common factor between 12 and 18. To simplify the fraction, I need to divide top and bottom over all of the common factors between 12 and 18. So one of the rules that I like to use, and it's easier than just listing all of the factors of 12 and then listing all of the factors of 18 and then circle the ones that are common and then divide. I mean, it's a manual way to do it. This is the essential way to do it. But another way to think about it is to look at the two numbers and try to think of the factor, maybe multiple factors, but we're going to start with one. So one of the rules I use is if I have two even numbers, 12 and 18, then 2 is for sure one of the common factors. Divide over the common factor and divide over the common factor. Divide 12 over 2 is 6, and then 18 over 2 will give you 9. I'm not done yet. 6 and 9. There is something common between 6 and 9. My knowledge of the multiplication table that 9 is a multiple of 3 and 6 is a multiple of 3. Then 3 is a common factor. Divide over that 3, eliminate that 3. I need to get to the core value of the fraction. 6 over 3 is what? 2. And 9 over 3 is 3. 2/3 is an equal fraction to 12 over 18. But think about it. If I am telling you, for example, I spend 2/3 of my income on living, rent and grocery and everything. Or if I tell you I spend 12/18 of my income on living, which one you can picture more in your mind and you're able to visualize what that would be? how much part or how big is your spending just for living? The 2/3, because this is the core value of the fraction. Later on, when we divide and add, the final answer that we have to give is a simplest form answer. So that's why we need to learn how to simplify fractions. Let's do B. 48 over 54. The same thing. I see two even numbers. So the first one of the factors, common factors, is 2. Divide and divide. 48 divided by 2 will give you 24. And then 54 will divide into divided by 2 will give you 27. Okay, 24 and 27, they are not even numbers, so I'm not going to think about the 2. But I know something about the multiples of 3. 24 is a multiple of 3 and 27 is a multiple of 3. Then 3 is again a common factor. Divide over 3 and divide over 3. 24 over 3 will give you 8 on the top, and 27 over 3 will give you 9. You may ask, when do I know I need to stop here? That 8 over 9 is the simplest form, because there is nothing common between 8 and 9, nothing common between 2 and 3. Think about the factors. Factors of 8. 8 and 1, 2 and 4, and that's it. What about 9? 1 and 9, 3 and 3. So nothing common. Do you see anything common? And that's why I had to stop here. Nothing to do further. The same thing with 2. 2 and 1 and 3 and 1. Well, 1 is a common factor, but if I divide over 1 and divide over 1, is it going to really help? No, it's going to give me 2 over 3. So we never take 1 as a common factor, although it is, but we do not use it to simplify fractions. So this is how I know 8 over 9 is the simplest form for this fraction. Last one, 27 over 90. Not even numbers, so 2 is not an option. What else? I need to think of in my mind what would be something common between 27 and 90. I know that there's something common between 27 and 9, which is 9, but I have 90 in this case. 9 would work again, because 90 is a multiple of 9 and 27 is a multiple of 9. Then use 9 over 9 and over 9 equals 2. 27 over 9 will give you 3 on the top, and then on the bottom it's 10. 3 and 10, nothing common between them. That's it. This is the simplest form of the fraction. Questions? Any questions? By practice, if you go to the study unit, if you do the self-checks or practice exercises, whatever they are called, or work it out exercises, if you do lots of these, you will get the hang of it. You will know which factor you need to eliminate, and you will know when to stop. Okay, let's move on to a self-check question. Simplify 24 over 32. So I'm going to leave you think about that and find the answer. Here you go. Okay, let me share my answer then. So to simplify that, I can just simply notice that 24 and 32, both of them are multiples of 8. I can just divide over 8, and divide over 8 equals to 3 over 4. Or another method, I would say, oh, 24 and 32, both of them are even numbers. Divide over 2 and divide over 2. 24 over 2, that will give you 12 on the top, and then 32 over 2 will give you 16 on the bottom. Divide over 2, even numbers. Divide over 2 will give you 6, and then that will give you 8. Oh, 6 and 8, even numbers. Divide over 2 and divide over 2. 6 over 2 will give you 3, and then 8 over 2 will give you 4. Same answer. So whatever method, you want to do it right away with the 8, or you want to break it down to choose here. Next, what is the difference between proper and improper fractions? So proper fractions are fractions to the definition. So 1/10, for example, 1/10 is a fraction to definition. Why? Because a fraction is a fraction of things. So if I have a pizza and I cut it into 10 pieces and I take one piece, it's a fraction. It's a portion of the whole pizza. So a proper fraction is always having the top number less than the bottom number. And in this case, we call that fraction a proper fraction. Improper fractions, they are fractions, but they are not really to the mere definition of fractions because it has the top number greater than the bottom number. If you look at that fraction, it's more than 1. It's more than 1. And the idea of fractions, that a fraction is a portion of 1. But since that fraction is greater than 1, then it is an improper fraction. And again, how do I tell if it's an improper fraction? If the top number is greater than the bottom number. Now, what if I have 7 over 7? They are equal. Do I call it a proper or an improper fraction? In this case, I call it an improper fraction because it is really a whole 1. It's equivalent to 1, and 1 is not really a fraction. It is a whole number. So that's why any number over itself, we call that an improper fraction. So this is how you tell. How would I change an improper fraction to a mixed number? A mixed number, as the name says, it's a mix of a whole number and a fraction. Example, if I have 3 and 1/5, that's a mixed number. It has a whole number part and a fraction part. It's a mixed number. So how do I change an improper fraction to a mixed number? The way we do that is to ask ourselves, how many times 4 goes into 15? How many times 4 goes into 15? You can do that mentally if the numbers are smaller. So you will think 4 times 3 is 12 by half 15. So let's go up. 4 times 4 is 16. 16 is greater than 15. I need to go down 1. So 4 times 3 would work. Actually, there is 3/4 in 15. So it is 3 as a whole number. And then 4 is the denominator. We're going to keep the denominator the same. And then figure out the remainder. 3 times 4 is 12. And then subtract. 15 minus 12 will give you that number, which is 3. Another way, easier way to figure out this 3, the whole number part, is to divide 15 using your calculator. Divide 15 divided by 4. It will give you 3 and some decimals. Ignore the decimals, take the 3, and that would be this 3. Keep the 4 the same, and then 3 would be the same method. 3 times 4 is 12. 15 minus 12 will give you 3. Let's repeat the same thing with B. 41 over 9 is equal what in mixed number? Let's do it the calculator way. So to know that, I'm going to divide 1 divided by 9 equals to 4 and some decimals. Take the 4, ignore the decimals. The denominator will be the same. It's going to be 9. Figure out the top number. How? Multiply 4 times 9. will give you 36. 41 minus 36 will give you 5. That's it. Any questions? Okay, let's do a self-check and see if you are able to apply the same thing when you are converting 135 over 11 to a mixed number. What would that be equivalent to in terms of a mixed number? And here you go. Okay, let me share my answer since we are getting tight here in time. So the answer is you are able to figure out that the mixed number for that improper fraction is 12 and 3 over 11. Next topic would be the opposite. If you are given a mixed number, how would you represent that in terms of an improper fraction? So the way we do that is multiply, then add. Okay, let's do that together. 30 times 7 will give you 210. And then add 210 to 5 will give you 215 on the top. Keep the same denominator the same, 7. And that's it. One more time, B, 10 and 10 over 13, 10 times 13, and then add to 10. So 10 times 13 will give you 130, plus 10 will give you 140. Keep the same denominator, 13. That's it. 2 steps only. Let's do one more self-check on that. 11 and 5, ninth. What would be that if we need to write this in terms of an improper fraction? Here you go. Remember that we multiply 11 times 9 and then add to 5. And I see that maybe you are some of you are multiplying 11 times 5. Let's do that question together then, just to clear up any confusion. So the way we're going to do that again is multiply and then add. So multiply 11 times 9, 11 times 9 equals to 99. And then add 99 plus 5 will give you 104. So the mixed number, the improper fraction for this mixed number is 104 on the top. Keep the same fraction on the bottom, 9. That's it. And that was it as far as math. We discussed how to compare fractions, how to find an equal fraction to another fraction, how to decide if two fractions are equal. We looked at the improper fractions, like fractions, and everything like that. This section of the unit is so important, as I said in the beginning, for the rest of the unit. So I hope when you get the recording, you watch it one more time at least to grasp everything that we need to cover and understand in this section. For the exam, do the self-checks or the practice questions. Sometimes there is like a work it out sections. So try these. Try to do these. The answer keys for all of that is provided as part of the course. So you will find it either by clicking here at the end of each self-check group. You're able to check your own answers just to know if you are on the right track or no. Or some of you may find the answers in a separate document under the course, a closer look answer key supplement. It has all the answers as well. Remember that the retake policy has changed, so if you fail an exam, you only can retake, and the maximum grade for that retake can only be 65. If you pass an exam with a low passing grade, there is no retake available, and that would be your final grade for the exam. So try your best to score as high as you can the first time. Resources, you can call the school 9 to 6 Eastern Time on weekdays. You can email the instructor through the help center through your student portal. You can watch the videos uploaded in the course space within your student portal. You can YouTube topics and see how do we change improper fractions to mixed numbers, for example. Khanacademy.org is free, and they have great instructional videos as well on math and other subjects. Thank you for everyone who attended. Thank you for asking questions and responding to the self-checks. If you happen to have questions more on that section, you can as well email, and please keep the title of the email something that does with math, so they would forward the email to the right department. Thank you so much for being with me, and I hope that you do good in the exam. Good luck, everyone.